Okay, so get this, right. Today we're going deep, like seriously back into a theory that says everything, and I mean everything, started with, you ready for this? Water.
Yeah, you heard right. Not just life, but the whole universe.
Hmm.
Maybe it all sprung from good old H2O.
I'm so ready for this. We're looking at this paper, right? It's called A Water First Cosmology, and it's mixing physics with some pretty out there ideas.
Well, yeah, I mean, the author, this guy L.S. Larkey, he starts off with a concept that's pretty wild, right? He says that water might exist in two worlds. So, like the physical water we see every day, obviously. But then there's this possibility it also exists in a hidden dimension, higher dimension.
Whoa, okay, two worlds. So like a parallel universe, but just for water. I don't quite get that.
Not exactly a parallel universe, no.
Yeah.
Think of it more like water having this connection to a realm beyond our senses. It's not a new idea, though. It kind of echoes throughout history. Like a lot of cultures and mystical traditions, they see water as this bridge between realms, not just a physical substance. Have you ever felt that? Like a deeper connection to water?
You know what? I've always felt like really drawn to the ocean. It's hard to describe, but there's this sense of peace and energy. I don't know. So how does this two worlds thing, how does it connect to the creation of the whole universe?
So the paper suggesting that water, being this, two-world traveler, was the very first thing to condense out of the vacuum of space. So picture this. The early universe is this giant swirling bubble of water shaped by magnetic forces.
You know what? I am picturing a cosmic water balloon. Is that way off base?
Uh-huh. It's simplified, sure, but yeah, it gets the idea across. And within this watery bubble, everything we know, like the ingredients for stars and planets, even us, it's all starting to come together.
Wait, hold on. How do you go from water to, everything else? Rocks, planets, stars? Those aren't made of H2O, are they?
That's where it gets, well, really interesting. The paper proposes that heavier elements, the ones that make up most of the matter we see, they could have actually formed from water.
Okay, now you have to explain this. That sounds like, I don't know, some serious alchemy.
All right, so imagine the vacuum of space, not as empty space, but as this, like, sea of potential energy that's constantly fluctuating. And under the right conditions, these fluctuations, they can create particles, even atoms.
So there's energy in the vacuum, but how does water actually transform into these heavier elements?
The paper suggests that water, because it exists in both the physical world and this hidden dimension, it can tap into the energy of the vacuum. In a way, other matter just can't.
So water acts as this, like, conduit. It uses the vacuum's energy to reshape itself into heavier elements.
That's the idea. They even have this mathematical model for how it might work, involving a Fibonacci-like sequence. It describes how heavier elements could form from water. They call it Fibonacci recursion.
Wait, Fibonacci sequences, like the spiral patterns you see in sunflowers. What do those have to do with the universe?
Okay, think of it this way. The arrangement of petals in a sunflower follows a mathematical pattern, right? Well, this theory is saying a similar kind of order maybe it governed how matter formed in the early universe, with water playing a central role.
Okay. I'm starting to see how it all connects, but transforming water into heavier elements, that is pretty radical, like compared to standard physics.
Oh, absolutely. It's a theoretical exploration, like a what-if scenario.
Yeah.
But the implications, they're fascinating.
So, all right, we've got this giant water bubble and heavier elements are forming. What's next? How do we get planets? Stars, dry land.
Well, as these heavier elements form, like silicon, iron, that kind of thing, they start clumping together.
Yeah.
It's happening inside this water-filled universe, like sediment settling in a lake, but on a cosmic scale, right?
Okay, yeah, I can picture that. So those clumps become dot planets.
Exactly. And as those protoplanets, as they grow larger and denser, they start to, emerge from that primordial ocean. It's almost like the biblical account of creation where it says, let the dry land appear. But this is on a grand cosmological scale.
Whoa. Hold on. Are we connecting, like, cutting-edge physics to the Bible now?
Not necessarily validating any one belief system, but it is interesting to see those echoes, how ancient stories sometimes touch on these profound ideas about the universe.
That is pretty mind-blowing. So from water to heavier elements to planets with dry land. But what about life itself? Where does that fit into all this water?
Remember how we talked about water existing in two worlds?
Mm-hmm.
Well, the paper says that this dual nature, that's what lets water contain something they call the living force.
Okay, living force. What is that exactly?
Think of it as this higher dimensional energy. It's what animates life, like a spark that exists beyond our normal perception. And because water can access this hidden dimension, it acts as this conduit, allowing the living force to come into the physical world.
So life as we know it can only exist because water's acting as this bridge between realms.
That's what the theory's proposing. It really makes you appreciate how special water is, doesn't it?
It really does. I'm looking at my glass of water a lot differently now. But this living force, can we actually measure it? Scientifically, I mean?
That's where things get a little more speculative. The paper doesn't propose any specific experiments to detect the living force, but it does point to some interesting geometric patterns. Might offer some clues.
Geometric patterns, like what? Give me an example.
Well, think about snowflakes. We see their six-sided symmetry, right? But this theory suggests they actually have 10 sides, 5 in our dimension and 5 in the hidden one.
Wait, a 10-sided snowflake? 5 sides hidden in another dimension? It's incredible.
And the Great Pyramid. We think it has 5 faces, but the theory suggests there are 10. 5 are hidden, just like the snowflake. They both offer glimpses into this deeper geometry.
So snowflakes and pyramids, they're like keys to understanding the structure of the universe.
Think of them as hints, pointing to something more profound underlying reality. And because water is so central to this theory, it suggests that water's unique properties might be directly connected to this hidden geometry.
My mind is officially blown. We've gone from the origins of the universe to hidden dimensions in snowflakes. But before we go too far down that rabbit hole, let's take a breath, recap what we've learned so far.
Good idea. It is a lot to take in.
Okay, so to sum up, we started with this incredible idea, right? The universe began as a giant bubble of water. Then, through some pretty unconventional physics, heavier elements formed from this water, leading to planets with dry land. And water's ability to exist in two worlds, that makes it the only thing that can hold this living force that animates all life. And on top of all that, we've got hints of hidden geometry in things like snowflakes and the Great Pyramid, maybe connected to water's properties.
That's a great summary. But there's still more to explore. We haven't even touched on how this theory connects to consciousness and the nature of reality itself.
Oh boy, this is going to get even wilder, isn't it? Well, listeners, you heard it here first. Stay tuned for part 2 of this deep dive, where we'll explore even more mind-bending ideas about water, consciousness, and the universe.
You know, this water-first cosmology really makes you think differently. Not just about the universe, but about consciousness, too.
Oh, okay. Now you've got me really curious. So we're connecting water to consciousness. Is this theory saying that water is, like, aware, sentient?
Not exactly sentient the way we normally think about it, no. But the paper proposes that consciousness, it might be a fundamental property of the universe, just like gravity or electromagnetism. And water, with its connection to this hidden dimension, could be like a pathway for consciousness to enter the physical world.
So water isn't conscious itself, but it's how consciousness, like, flows through things.
Yeah, that's a good way to think about it. Think of a radio. The radio itself isn't the music, right?
Yeah.
But it picks up the radio waves, transmits them. So in this analogy, water's like the radio, and consciousness is the music.
Okay, that makes sense. I get the analogy. But if consciousness is like this fundamental thing in the universe, doesn't that mean that everything is conscious, not just living things?
Well, that's a question philosophers have been debating forever. This theory doesn't exactly say everything is conscious, but it suggests that, maybe consciousness is more widespread than we realize.
So a rock could have some level of consciousness, just not in a way we can easily understand.
It's a possibility. The paper even points out that even in regular physics, everything is energy, right? It's just vibrating at different frequencies. Maybe consciousness is just another kind of vibration. And water, with its, unique properties, it's really good at resonating with those vibrations.
I have to admit, my mind is completely blown. We've gone from the beginning of the universe to the nature of consciousness, and it all comes back to water. Is there more to this theory? What else does it cover?
Well, there is one more concept, and it is mind-bending. The paper explores the idea that time itself, it might be different in this hidden dimension that's connected to water.
Wait, time. Okay, I might need you to slow down a bit here. Walk me through this one.
So we experience time as linear, right? It flows from past to present to future. But some physicists think that time might be a lot more complex, maybe even multidimensional.
Multidimensional time? You mean like multiple timelines happening at the same time? Are we going full back to the future here?
Not exactly time travel, no. But the idea is, in this hidden dimension, time might not be limited the same way it is for us. It might flow differently, or even exist as a kind of a timeless present.
A timeless present, like everything's happening at once. I'm trying to wrap my head around that one.
I know, right? The really tough concept to grasp. We're just so used to linear time. But think about it. If water can exist in both the physical world and this hidden dimension where time works differently, maybe it can access information from all points in time, like all at once.
So water could be like a living library of the universe, containing information from the past, present, and future.
That's one way to put it. It makes you wonder what secrets water might be holding, right?
We've been talking about water like it's this, I don't know, this mysterious, mystical thing, but it's
Yeah.
also something we use every day. So does this theory, does it change how we should think about water in our daily lives?
Absolutely. It encourages us to see water with, well, more respect, more
Yeah.
awe, to recognize that it's not just, a simple molecule. It's something far more profound connected to, like, the fabric of reality.
I'm definitely looking at my glass of water a lot differently now. It's like holding a tiny piece of the universe's mystery.
Yeah, and that sense of mystery, it's something to treasure. It reminds us of how much we still don't know.
That's a good point. So let's recap some key ideas here. This deep dive into the water first cosmology. We talked about how water might be a conduit for consciousness, suggesting that consciousness could be this fundamental property of the universe itself.
And we went deep into the idea that time operates differently in the hidden dimension that's connected to water, maybe even existing as this timeless present where information from all points in time is accessible.
And I think the most important thing is this theory makes us rethink our whole relationship with water, recognizing that it's profoundly connected to the essence of reality.
It's amazing, isn't it? How something as simple as water can lead to these, like, incredibly profound insights. We haven't even talked about how this might change our understanding of physics.
You're right. The paper also explores how this water-first cosmology could challenge some of the most basic principles of physics, like gravity and even the speed of light.
Yeah, exactly.
Yeah.
It suggests that some of the most basic assumptions we have about the universe might need to be re-examined with this new perspective.
Well, listeners, it seems like we need one more deep dive to really unpack this whole water-first cosmology. Stay tuned for part 3, where we'll venture into the mind-blowing world of water-first physics. Okay, so we're back, and we're ready to finish this deep dive into water-first cosmology. And this is where it gets, well, really mind-bending. We're talking about how this theory could totally change how we understand physics.
Yeah, this isn't just like a little tweak to what we know. It's challenging some really big ideas in physics, like gravity, the speed of light, even what matter and energy actually are.
Hit me with it. My reality is ready to be totally reshaped. Where do we even start? What part of physics does this theory really turn upside down?
Well, one of the biggest changes is how elements are made. The paper calls it vacuum-assisted transmutation. Basically, it says that water can turn into heavier elements, but not through the usual nuclear reactions we know about, but by using energy from the vacuum itself.
Wait, hold on. Turning water into other elements, isn't that like alchemy? Turning lead into gold?
It does sound kind of like an ancient myth.
Yes.
But in this theory, it's not about magic. It's about understanding how matter and energy interact, but like at the most basic level, from a completely different perspective.
Okay, my brain is trying to keep up. How does this vacuum-assisted transmutation actually work? Explain it to me like I'm 5.
All right, so imagine that the vacuum of space isn't emptiness, but it's more like an ocean, but an ocean of energy. And this energy, it's always fluctuating. And under the right conditions, those fluctuations can create particles, even atoms.
So far, so good.
Hmm.
But where does water fit into all this?
Remember the idea of water existing in two worlds, one physical and one hidden. Well, this theory says that water, because it's connected to that hidden dimension, it can use the vacuum's energy in a way that other matter just can't. It can actually restructure itself, rearranging its hydrogen and oxygen atoms to make heavier elements.
So water's like some kind of, I don't know, a cosmic chef, using the vacuum's energy to whip up some new ingredients.
Uh-huh, yeah, that's a great way to put it. And they even have this mathematical model for how it could work. It uses something called Fibonacci recursion, which is like a Fibonacci sequence describing how those heavier elements could gradually form from water.
Fibonacci sequences, again, they're everywhere in this theory, huh?
It seems like they are a recurring theme, yeah.
Yeah.
But what's really mind-blowing is what this idea means for physics. It challenges everything we thought we knew about how elements are formed. It suggests that the vacuum itself, it plays a way bigger role than we ever thought.
So all those nuclear reactions in stars, that's not the whole story.
This theory suggests that it's an incomplete picture. And it doesn't stop there. It also changes how we think about gravity.
Okay, lay it on me. How does water-first cosmology change how we think about gravity?
Well, in standard physics, gravity is a force of attraction. between things that have mass. This theory says it's more like a pressure difference created by the vacuum.
So instead of objects pulling on each other, they're being pushed together by the vacuum?
Exactly. Think of two balloons underwater. They get pushed towards each other because of the water pressure, right? So in this theory, the vacuum is like the water, and objects are like those balloons.
Whoa, that's a real shift in how I see things. So gravity isn't coming from the objects themselves, but from the fabric of space and time.
Yeah, that's closer to how this theory sees it. And that has some pretty wild implications for things like black holes and the expansion of the universe, stuff we thought we understood pretty well.
All right, my head's spinning a little, but there's one more big one I have to ask about. Einstein's theory of relativity. That whole nothing can travel faster than light thing. Does this theory mess with that too?
It doesn't exactly contradict relativity, but it does suggest that maybe this speed of light isn't the absolute limit that we always thought.
Wait a minute, are we talking faster than light travel here? Because that would be huge.
Not faster than light travel exactly, but maybe there are ways to, like, get around those limitations of space-time. Like, imagine instantaneous communication or even traveling really far distances without those time constraints.
Okay, now we're talking. How could something like that even be possible?
Remember we talked about time being different in that hidden dimension connected to water? Well, if we could somehow tap into that dimension, we might be able to bypass those limits of time and space that we're stuck with.
So it's not about breaking the speed of light, but more like finding a shortcut through, like, reality itself.
Yeah, that's the idea. And water, because it's linked to that hidden dimension, it could be the key.
This is seriously mind-blowing. And I feel like we've only just scratched the surface of what water-first cosmology could mean.
Oh, we've only just begun to explore the possibilities, really. His theory raises way more questions than it answers. But that's what's so exciting about it. It makes us think beyond what we thought was possible.
That's true. So, as we wrap up this deep dive, what's the one thing you hope listeners take away from all of this?
I think the biggest takeaway is just how amazing water is. It's a profound mystery, and it could be the key to unlocking some of the universe's greatest secrets. The next time you see a drop of water, really look at it. Who knows what incredible discoveries are waiting for us as we explore the wonders of water.
Beautifully said. And on that note, we'll leave you to ponder the mysteries of water and the universe. Thanks for joining us on this journey, and until next time, keep your minds open and your curiosity flowing.